This last lab, pH buffers and titration, is based on your chapter 9, Introduction to Acids and Bases. The earliest definition of acids and bases was suggested by Swedish chemist Svante Arrhenius in the late 19th century. And according to Arrhenius, an acid contains a hydrogen atom and dissolves in water to form a hydrogen ion. On the other hand, a base is a substance that contains hydroxide ion and dissolve in water to form hydroxide ion. For example, let's say HCl, I'm talking about hydrogen chloride gas. It's an acid. Why? Because when you dissolve it in the water, it forms H plus ion and Cl negative. So it is forming an hydrogen ion, hydrogen with 1 plus charge. So that's why HCl is an acid. Similarly, sodium hydroxide is a base. Why? Because when you put it in the water, it forms sodium ions, or I should say it dissociates to form, release sodium ions and hydroxide ions. So this hydroxide ion is coming from here. Now, Arrhenius' definition can correctly predict the behavior of many acids and bases, but this definition is limited and sometimes it is inaccurate. For example, when we say acid, it forms hydrogen ion, H plus does not exist in the water. So why? Because when H plus is formed, it immediately reacts with the water to form H3O plus ion, hydronium ion. So there is nothing like H plus in the water. Another thing is there are so many acids and bases that we cannot call them acids or bases based on Arrhenius' definition. For example, NH3, ammonia is a base. But if you look at this, there is no OH. It cannot donate OH negative. So I cannot explain ammonia as a base based on Arrhenius' definition. So the next, or as a result, a more general definition of acids and bases was proposed by Bronsted and Lowry, Johannes Bronsted and Thomas Lowry, in the earlier 20th century, and this is used widely. According to Bronsted-Lowry definition, acid is a substance that donates proton. Means acid is a proton donor. And what is proton? Proton is hydrogen with the positive charge. And base is a proton acceptor. So if a substance can donate the proton, it's an acid. If a substance is accepting the proton, it's a base. To be a Bronsted-Lowry acid, of course, the substance needs to have hydrogen to do this. and to be a Bronsted-Lowry base, the substance should be able to accept the proton. That means it needs to have a lone pair. Lone pair, of course, this is a negative charge, and negative charge attracts positive charge. So look at this reaction. H2SO4, sulfuric acid, when dissolved in water, produces hydrogen sulfate ion and hydronium ion. Now, these are my two reactants. One of them is an acid and one of them is a base. How will we find out which one is an acid and which one is a base? By looking at the products. So look here, H2SO4, and look at it, how it's changing. It is changing to HSO4 negative. Is it donating H plus or is it gaining H plus? So when you have H2SO4, let's just write down positive negative on the top. Positive negative means nothing, neutral. So if I get rid of H plus, means one hydrogen and one positive charge. If I get rid of it, then what will be left? One hydrogen, SO4, and then one negative charge. So that means sulfuric acid is donating the proton. So sulfuric acid will be, now we're going to call it an acid. Look at water, H2O is changing to H3O plus. So if I add H plus into it, so there are total 3 hydrogens, oxygen, and one positive charge. That means water is accepting the proton. That means it is a base. You decide which one is an acid and which one is a base by looking at the products. Now acid, after loses its proton, so here is the acid. Let me erase a few things. So acid, once it is done losing the proton, forms conjugate base. So what does that mean? This was my acid, and after losing the proton, it is forming HSO4 negative. We call it as conjugate base. This was my base, water, and base after accepting the proton forms conjugate acid. Let's look at another example. Bicarbonate ion here reacts with water to produce carbonic acid and hydroxide ion. Now out of these two, which one is an acid and which one is a base? Again, look at it. On this side it is HCO3 negative, and HCO3 negative is changing to H2CO3. From left to right, you can go by adding H plus, because look, one H plus H makes it 2. Positive and negative cancel out, and we will have this. That means this substance is accepting the proton. Because we are adding the proton in it, it is going to be base. And base, after accepting the proton, forms the conjugate acid. Now water, if bicarbonate is a base, then water has to be acid. But let's check. If it is an acid, then what does acid do? Acid donates the proton, gets rid of the proton. So here is my water. If it's a neutral substance, put plus minus on the top to just check what the conjugate base will be. And if it is donating the proton, then let's get rid of one hydrogen and one positive charge. Then what is left? One hydrogen and one OH negative. And that's what is happening here. So if water is an acid, it means it's donating the proton and forming OH negative, so it will be a conjugate base. So in these examples, if you see, we just cannot say, oh, these substances are definitely going to be acids and these ones definitely will be a base. You have to look at the reaction and you have to look at the products. In the first example, H2O was acting as a base. In the second example, water was acting as an acid. So the substances that can act both acids and bases are known as amphoteric substances. So water is amphoteric. Water can act as both acid as well as base. So if given the reaction like that, you should be able to label them as acid base, acid, conjugate base. Now, what if the question is simply you are given a formula of an acid and you have to write down the conjugate base? Then you have to think about the definition of an acid. What does acid do? Acid donates the proton, get rid of the proton. If it is a neutral substance, just put plus minus on the top. Get rid of proton means get rid of H plus, that's proton. What is left? Cl negative. So acid makes conjugate bases. How will you write down conjugate bases? By subtracting H plus. Similarly, H2SO4, here write down plus minus, get rid of H and 1 plus sign. What will be left? HSO4 negative. If the base is given and you are told to write down the conjugate acid, then you have to think about the definition of a base. Base accepts proton. That means now in this one you have to add H plus. So I have HSO4 negative and I'm adding H plus into it. H and H, 2H means H2, SO4, and there was one negative and one positive, that cancels out. Next, ammonia, base accepts proton. So if I'm adding H plus into it, so N, how many total hydrogens are there now? 4, 3 plus 1, and then there is 1 plus charge. So NH4 with 1 plus charge is a conjugate acid of the base ammonia. Now, bronzed acids may contain one or more protons that can be donated. For example, look at HCl. HCl has only one hydrogen. That means it can donate only one proton, H with the positive charge. So if it has only one acidic proton means the proton that can be donated is called the monoprotic acid. How many hydrogens do you see here? 2. This is a diprotic acid, means it has two acidic protons. It's very important that you're saying 2 acidic protons because not all the hydrogens can be donated. Hydrogen has to be attached to a electronegative element, to strong highly electronegative element and to be an acidic proton. Look at this H3PO4. There are 3 protons and they're all acidic, means you can donate all of them. That is the triprotic acid. Now one thing is, if you see a hydrogen attached to nitrogen, oxygen or fluorine, those will be acidic hydrogens, means they can be donated. The next topic is the acid base strength. Acid can be strong or weak. A strong acid means it readily donates a proton, means when you put the acid in the water, it dissociates 100% to form the ions. This is the list of 7 strong acids and you need to know these. For this class, all other acids we are going to consider them as weak acids. So let's say HCl is a strong acid. What does that mean? That means when you put that into the water, we just put a single arrow and it breaks down 100% to form the H3O plus and Cl negative ion, and there is no intact HCl left. It's an acid. Acid donates proton. So this is the conjugate base. Base accepts the proton. On the other hand, if you have weak acid, let's say for example acetic acid, it less readily donates the proton, means when you dissolve it in the water, only a fraction of this acid dissociates. So we show this with 2 arrows equilibrium sign, and yes, acetic acid is breaking down to produce these ions, but we have a lot of intact acetic acid present there too. So that means we have all these things present. So we show it with this double arrow, again the reversible equilibrium sign. Um, that's the same thing with bases. A strong base like sodium hydroxide, when you put it in the water, it breaks down immediately to form Na plus and OH negative. On the other side, if you take a weak base and put it in the water, it breaks down to form the ions, but we still have a lot of intact base left too. Um, this reaction here, when I'm dissolving it in the water to form this, that's the completely detailed reaction. Sometimes we just write it down like this uh, to, to just simplify things like this. Acetic acid is breaking down to form these ions, but since it's in the water, eventually H plus will react with water to form the hydronium ion. So basically H3O plus and H plus kind of show the same thing. Truly speaking, there is nothing like H plus because H plus in the water is H3O plus.